All right, the last review day before I give you guys the take-home test. It's limits involving 0 over 0. The directions are going to say, evaluate the limit. Is the x value continuous or discontinuous? So that's all you need to do. That's all you need to do. And you're allowed to use the factoring method or L'Hopital rule. Remember, you can only use L'Hopital rule for 0 over 0. It doesn't make sense to do L'Hopital rule when it isn't 0 over 0. So let's take a look at problem number 1. The limit as x approaches 7 for x squared minus 49 over 2x minus 14. So what do I always do? Direct substitution. In your noodle, you're going to get 7 squared minus 49 over, so I got 49 minus 49 over 2 times 7 minus 14. I get 14 minus 14. You know the deal. I plug in direct substitution, x equals 7, and I fail. Isaac Newton throws a chair through the window. There's a hole in the graph. The x equals 7 is discontinuous. But now I'm trying to figure out, well, where would that hole actually be in the graph? Where is it supposed to be? So I'm going to do this using the factoring method because that's what's expected of you in August or September of 2020. So I've got the limit as x approaches 7 for x squared minus 49 over 2x minus 14. So on the top, I've got x squared minus 49. That's the difference of two squares. You know what that means. Straighten the tie. We've got a pair of conjugates. X plus 7, x minus 7. And on the bottom, we've got 2x minus 14. Can I factor that? Oh, yeah. Go back to Algebra 1. I know. I got a GCF of 2. So I'm going to factor out the 2. And that leaves me with 2 times what is 2x? 2 times what is negative 14? Anybody see the problem with this function? Well, when I plug in x equals 7, that x minus 7 over x minus 7 creates a 0 over 0. That'll be $400. There's the problem. That's why the graph is 0 over 0, because actually the graph is y equals x plus 7 over 2. We just say that there's a hole at x equals 7. So we've got the limit as x approaches 7 for x plus 7 over 2. Now is direct substitution legal? Yeah. So now I'm going to plug in 7. I can see where this is going. 7 plus 7 over 2, or 14 over 2, or 7. So, as x gets closer and closer to 7, y also gets closer and closer to 7, so there should be a hole. There should be a point at 7, 7, but the point 7, 7 is discontinuous. Therefore, x equals 7 is discontinuous. That's all you need to do. Oh, wait. Am I limiting you to just factoring? Dude, play with your toys. It's all right. L'Hopital. Everybody say L'Hopital. And the only reason L'Hopital works is because of that hole. It does not work otherwise. So, I'm going to put L'Hopital over my equal sign. So the limit as x approaches 7. Remember, function does not equal its derivative, so you have to indicate I used L'Hopital rule. Otherwise, college professors get mad. So now, what is the derivative of the top? 2x, and that negative 49 goes away. What is the derivative of 2x minus 14 with respect to x? 2. And I could just cancel out the 2's right here, leaving me with the limit as x approaches 7 for x. So I'm going to do that. Or I could just do 2 times 7 over 2. So I'm just going to cancel that part right there. So I've got the limit as x approaches 7 of x. Y equals x, basically. And so now I'm just going to plug in x equals 7, which is resulting in y equals 7. But the idea is because I had to use L'Hopital rule for 0 over 0, x equals 7 is discontinuous. Okay, I just showed two ways of getting the exact same thing. But you must show that it resulted in 0 over 0, or at least indicate to me, hey, I tried direct substitution and it got me 0 over 0. But that's why it's discontinuous. Okay, number 2. And I just put these out here rapid fire, numbers 2, 3, 4, and 5, just to get you comfortable for what's coming up in August when you guys go to college, leave me and never come back and visit. Anyway, so 2x minus 13 is the function, but we're trying to approach x equals 15 from the left and the right. So as x gets closer and closer to 15, where does y want to go? First things first, is it legal for me to plug in x equals 15? Yeah, there's nothing wrong. There's nothing on the bottom. There's nothing illegal about x equals 15 for y equals 2x minus 13. So I'm literally just going to plug it in. 2 times 15 minus 13. So 2 times 15 is 30 minus 13. And that's going to get me 30 minus 10 is 20, 17. So what does this mean? Because direct substitution was no issue at all, it's good. That means x equals 15 is continuous. There is nothing wrong with just plugging in x equals 15. Hooray! All right, so we've got the limit as x approaches negative 9 for the square root of x plus 45. What's my first move? Direct substitution. Is there a problem with plugging in x equals negative 9? No. So I'm just going to plug it in. The square root of blank plus 45. And what goes in for the input x? Negative 9. So then I just plug it in and do negative 9 plus 45 and get the square root of 36, or 6. So because direct substitution worked, is x equals negative 9 continuous or discontinuous? X equals negative 9 is continuous. All right, number 4. The limit as x approaches 12 for the absolute value of negative 5x. What's my first move? Direct substitution, yeah. So I'm just going to plug in absolute value bar negative 5 times x, and I'm going to plug in 12. So therefore, negative 5 times 12 is negative 60, but remember that's in the absolute value. The absolute value of negative 60 is still 60. You know the deal. Direct substitution worked, so x equals 12 is continuous. All right, number 5, just to get your trig, just to keep you familiar with trig, you might have the limit as x approaches pi. Is there a problem with x equals pi in your calculator? I'll give you guys time to plug it in. Well, again, the short answer is no, but just to refresh your memory, remember that pi is 180 degrees in the unit circle? So if I go to pi, That's 180 degrees. What's the x value on the unit circle? That'd be -1. So the cosine of pi is -1. Therefore, x equals pi is continuous. Okay, focus. There we go. So I just gave you like all the continuous ones out of the way. Just wanted to show you that there are some in there where direct substitution does work. Okay. Number 6, the limit as x approaches 1 for x squared minus 3x plus 2 over x squared plus 5x minus 6. What's my first move? You can tell by the thought bubble that you already know. My first move is to apply direct substitution. So I'm going to do blank squared minus 3 blank plus 2 over blank squared plus 5 blank minus 6, and each part of this rational function is going to get x equals 1. And the beauty of x equals 1 is it's such a beautiful multiplication problem when I could just do 1 squared, 1. Oh, I don't want blue, I want black. So I want 1 squared, which is 1. Negative 3 times 1 is negative 3. Plus 2. 1 squared is 1. Plus 5 times 1, which is 5. And minus 6. 1 minus 3 is negative 2. Negative 2 plus 2 is 0. 1 plus 5 is 6. 6 minus 6 is 0. What do you know? We've got a hole in the graph, making x equals 1 discontinuous. So I'm going to do this problem using factoring, just to keep your mind sharp. So the limit as x approaches 1, and I want to factor the top. What two numbers multiply to positive 2 and add to negative 3? Well, it has to be a negative-negative combination, specifically x minus 2, x minus 1. What two numbers multiply to negative 6 and add to 5? Well, x plus 6, x minus 1. Ah, there you are. You're the reason why it's 0 over 0. I got you now. So there's the source of why there's a hole at x equals 1. Now I can rewrite this problem. Sorry, I'm just trying to move it. The notebook was about to fall off. The limit as x approaches 1 for x minus 2, x minus 1 over x plus 6, x minus 1 can just be rewritten as x minus 2 over x plus 6. Now is it okay for me to plug in x equals 1? Yep. So I'm going to plug in x equals 1. So then I get 1 minus 2 over 1 plus 6. 1 minus 2 is negative 1. And 1 plus 6 is 7. So the whole thing, you know, it can't be reduced, but I'm just going to rewrite it as negative 1/7 where the negative is in the middle. That's just my personal preference. But if you wrote it as negative 1 over 7, I'm not going to get mad. What's the big picture? Is x equals 1 continuous or discontinuous? There's a hole in the graph, so x equals 1 is discontinuous. Right? So what if you don't like to factor? Fear not. All you need to do is show that there's a 0 over 0. So you do technically need to show that there's a 0 over 0 to use L'Hopital, or just tell me I plugged in x equals 1 and it got me 0 over 0. So with that being said, L'Hopital to the rescue. The limit as x approaches 1 for x squared minus 3x plus 2 over x squared plus 5x minus 6 can be rewritten if I take the derivative of the top over the derivative of the bottom, but only for x equals 1. So let's take the derivative of the top. And let's take the derivative of the bottom. Now, is it legal for me to plug in x equals 1? Yeah. So I'm going to plug in x equals 1, specifically 2 times 1 minus 3 over 2 times 1 plus 5. Well, 2 times 1 is 2. So 2 minus 3 is negative 1. 2 plus 5 is 7. I still get negative 1/7. Therefore, because I got 0 over 0, and I had to use L'Hopital rule, x equals 1 is discontinuous. Yeah. Right, 2 more problems. Just wanted to show you, what if you get something like this? Well, you've got a calculator. I'm going to plug in x equals 0 for x over tangent of x. So 0 over tangent of 0, you probably guessed it already, 0 on top, and the tangent of 0 radians is also 0. I'm not happy. So normally I would suggest something like factor. I don't know about you, I can't think of a way to factor this, so I have no choice but to go to my old buddy. I wasn't alive back then, but I'm going to call him my buddy regardless whether he likes it or not. My good buddy, L'Hopital. I don't even know what astrological sign it is. I don't know, maybe he's a Sagittarius or something, I don't know. The limit as x approaches 0. I'm going to differentiate the top and bottom. The derivative of x with respect to x is 1. And the derivative of tangent of x is secant squared of x. And I just wanted to put this in there just because. So I can rewrite this problem. Go back to your trig proofs. Remember that secant is the reciprocal of cosine. So I'm going to rewrite this problem as the limit as x approaches 0. So this is just 1 over secant squared. Well, why not just write this as cosine squared over 1? Or you know what? Cosine squared of x. I just wanted to show you guys a fun one. This isn't going to be on the test. But now, is it legal for me to plug in x equals 0? Yeah. So I'm just going to do cosine of x. I'll just rewrite it like this. So now I'm going to do cosine of 0 getting squared. Remember that the cosine of 0 is 1. So just to show my work, this is 1 squared or 1. Now, what's the main idea? Because I got 0 over 0 by direct substitution, this point is a whole. Therefore, x equals 0 is discontinuous. Okay. And finally, the last problem, and then I'll send you guys out the test. I wanted to show you something like this. No, a decimal's not going to be on there, but you might get a college professor who loves his decimals. And yeah, you could factor the top, and you could factor the bottom. But you know who I'm going to call. Nope, not the Ghostbusters. I'm going to call L'Hopital. So I'm going to differentiate the top and differentiate the bottom. The derivative of the top is going to be 30x minus 8 over 40x minus 14. And now I'm going to plug in 1.2 to the top and bottom of this function. So 30 times 1.2, why do I have a feeling that's going to be 36. So 30 times 1.2 is going to be 36, and 40 times 1.2. Oh, wait, 40 times 1.2, sorry about that, is going to be 48. So 36, 48, minus 8, minus 14. 36 minus 8 is going to be 28. And 48 minus 14 is going to be, I believe, 34. And please reduce this. I can divide the top and bottom for sure by 2, so that's going to be 14/17. Well, the limit as x approaches 2 for this gigantic function, I did the work for you because I wanted to save you guys some time. It resulted in 0 over 0, so I am not happy. Therefore, I got the hole in the graph, but remember, it's still a hole, so x equals 1.2 is discontinuous because direct substitution didn't happen and blah, blah, blah. But that's all you really need to know. So I'm going to Google share with you the L'Hopital rule test for 0 over 0 limits. What are we doing next? We're going to do more limits, but they're going to involve infinity. So specifically, what does the limit as x approaches infinity do? Or what happens when I get a vertical asymptote? So the limits involving the concept of infinity is the next topic. Hope you guys have a great weekend. I'll hand you guys out the test. You have until Monday night to do it. By the way, another announcement I want to make. They're changing the schedule. So instead of Monday, Tuesday, Thursday, Friday, they're taking away Tuesdays to make it social hour. So it's going to be 3 days a week as opposed to 4 days a week that we're going to have math. So you have Monday to do it, and then next Thursday we're going to be doing limits involving the concept of infinity. Have a great weekend.